Sub1 Reloaded. The current record for the fastest time to solve a Rubik's Cube is currently 3.47 seconds by Yu Shengdu from China. He broke the previous record in 2018, and although it sounds incredible, robots can solve Rubik's Cubes in way less time. In January 2016, a robot named Sub1 showed an unbelievable result of 0.887 seconds. Its developer, German expert Albert Beer, however, decided not to stop there. In November 2016, he presented the Sub1 Reloaded, an updated version of his robot. It could solve a Rubik's Cube in just 0.637 seconds. The system consists of a laptop that works in conjunction with a special machine. Using a camera, the system scans the puzzle, analyzes the positions of the colors, calculates the options, and makes a decision. It takes it milliseconds to perform these calculations and solve the Rubik's Cube. It doesn't sound too sophisticated, but it took about 2,000 hours to create this robot. Raptor. Here's another record-breaking robot. Raptor is a two-legged robot developed by the Korean Institute of Science and Technology. It was first shown in 2014. The maximum speed that it can develop is 46 km/h, which makes the Raptor the second fastest robot in the world overall, and the fastest two-legged robot. And its name is pretty suggestive. As you can see, its legs resemble the limbs of the bipedal dinosaurs that once roamed the Earth. It even has a tail that works just like the tails of an animal. It helps keep balance. The Raptor weighs 3 kilograms and is 47 centimeters tall. IRB-760FX. Not all robots are designed for research purposes. This model, for example, performs quite specific practical tasks. The IRB-760FX is an amazingly productive, specialized robot. It's designed for the high-speed press automation application. The robot is equipped with a large number of different working elements. They're used to lift standard-size loads and workpieces, and then carry or move them. The IRB-760FX is one of the fastest machines on the market today. Its speed is, on average, 15 to 20% higher than that of its competitors. At the same time, it stands out for its smooth movements and unique repeatability. This model is designed to lift loads weighing up to 100 kilograms. Its working radius is 3.2 meters. However, if necessary, the robot can be equipped with a tool to increase the working radius by 1.65 meters. Remarkably, despite its many advantages and impressive power, the IRB-760FX is compact. The robot, as well as the press line, doesn't take up much space, and it can be used in confined areas. OutRunner. The robots that are created today in universities and laboratories are usually prototypes that exist in one copy. For the most part, they're designed to test and improve different technologies and their practical applications. But right now, you are seeing OutRunner, an exception to that rule. Why? Well, in the first place, it's a robot designed primarily to entertain the user. And secondly, the developers from Robotics Unlimited are raising money for its mass production. OutRunner, as you can guess from the name, is a running robot. Its 6 legs have a unique design that was inspired by biology. The mechanism mimics the movement of legged animals, distributing the body weight accordingly. It's noteworthy that OutRunner can easily outrun a person, thanks to the fact that it can reach a speed of up to 32 km/h. When this was achieved during the trials, the robot and its team of inventors broke the world's speed record among tiny robots. Moreover, OutRunner works flawlessly and is quite stable without having complex control algorithms or expensive sensors. The robot moves on virtually any type of surface. It has a technology that stores kinetic energy while moving, so the battery lasts for 2 hours. Everything we told you applies to the $800 performance model. But you can buy a simpler model, the OutRunner Core, for only $250. It can speed up to 16 km per hour and works for up to 1 hour. Forpheus. And here's another robot that deserved a place in the Guinness Book of Records. Forpheus is the brainchild of the Japanese company Omron. This intricate device is actually a ping-pong coach. The engineers put in a lot of effort to make Forpheus a worthy opponent for even a professional player. In order to perform its functions, the robot uses cameras and special sensors. They analyze the position of the opponent's body, his movements, as well as the ball's travel. Deep analysis is performed every millisecond, so Forpheus can always predict the trajectory of the ball and hit it back. But there's more. During the game, the AI determines the opponent's skill. Then, Forpheus studies this information to develop an optimal training program. It's hard enough to be challenging for the user without being too frustrating, so it motivates the player and increases the efficiency of training. Mabel. Despite the fact that today's last robot is not a record holder anymore, we still couldn't help but include it in our list today. Because Mabel is a very fast robot. It was developed by researchers at the University of Michigan. It was shown for the first time in 2009, and back then it was the fastest robot on the planet. The engineers managed to teach the two-legged robot to speed up to 13 km per hour. The design, as you can see, is not really that compact. The robot weighs 65 kilos, and most of the mass is in the upper body. While developing Mabel, the researchers were guided by the idea of creating a robot that would be able to run fast, but at the same time adapts to any terrain and use electricity as efficiently as possible. And as you can see, they did a great job. Salto. Even though this robot looks tiny and weighs only 100 grams, it's a very sophisticated and technologically advanced machine that can perform many different, unusual, and impressive tricks. Salto was developed by researchers at the University of California in Berkeley. The very first version was shown in 2016. It could tilt forward and backward, jump and bounce off a wall. The robot actually behaves more or less like a pendulum. The movement changes depending on how hard the robot pushes off, as well as the angle of its leg at touchdown. The first version, however, could not move along a trajectory by itself. The robot could calculate and perform jumps, but it needed location data to do that. They were registered by a person using infrared markers and several cameras, and then sent to the robot almost manually. The latest version of Salto, though, was shown about a year ago, and finally, the robot learned how to collect all the necessary information by itself. Studies have shown that in 200 seconds, Salto is capable of jumping over 300 times, and every time it jumps, the robot knows exactly where it's going to land. The margin of error is only a centimeter. The maximum jump height is 120 centimeters, and the robot's speed varies from 13 to 16 kilometers per hour.